am Professor Tulshibiyam from ADSUL'S Technical Campus, Chas, Ahmedabad. Today we discuss very important topic of power system, that is transformer. So in the transformer topic we have to discuss definition, principle, after that construction parts of transformer, and after that types of transformer and the comparison between them. Okay, let us start the session. So first of all, what is transformer? Definition of the transformer. Transformer is a static piece of apparatus, that means where no any kind of moving part is present. Okay, transformer is a static piece of apparatus which converts electrical power, that is voltage and current, from one alternating circuit to another alternating circuit with desired changes in voltage and frequency. But transformer doesn't convert or doesn't changes in the frequency. Okay, this is the definition of transformer. Means transformer changes electrical power, that is voltage and current, from one alternating circuit to another alternating circuit. Okay, so what is the so we discuss the transformer by this simple diagram. This is suppose this is the transformer, and transformer always have two sides. First is primary side, second is secondary side. If the electrical power supply input is given to this side, then this side is called as primary, and if you take a load from this side, then this side is called as secondary side. Consider it is a primary side. Here we are given electrical supply, that is AC supply to this side, then this side having changes in voltage, magnitude of voltage and current. Okay, but here doesn't changes frequency. Here is 50 Hz frequency, we got here also 50 Hz frequency. Okay, this is the basic of transformer, and the rating of transformer is always measured in kVA, that is kilovolt ampere. Transformer doesn't measure in transformer's unit is not kilo farad, because transformer is always measured in volt ampere. Okay, now what is the principle of transformer? What is the principle of transformer? The transformer is always work on the principle of mutual induction. Okay, transformer is always work on the principle of mutual induced EMF. Transformer always work on that principle. Then what is the principle of mutual induction? So let us discuss about that principle. When it is explained by the circuit diagram. Suppose this is the core of transformer, and primary winding is moved on this side or this lane, and secondary load side winding is bound on this lane. Okay, this is the primary side of transformer. If we given electrical supply to the primary winding, the alternating current passes through the primary winding. If the alternating current passes through the primary winding, it produces magnetic flux. And if the current is alternating, then the produced magnetic fluxes are also in alternating nature. That means primary winding produces alternating magnetic flux. These fluxes continuously generates and travel through the magnetic core. While these fluxes are traveling through the magnetic core, it passes through the secondary winding. If these fluxes passes through the secondary winding, here these fluxes are passes through the secondary winding, then the secondary core, then secondary winding get induced EMF by the Faraday's law of electromagnetic induction. So by the Faraday's law of electromagnetic induction, an EMF get induced in the secondary winding. As the fluxes are in alternating nature, the generated EMF is also in alternating nature. Okay, this is the principle of transformer action. Okay, now what is the construction of transformer, or what are the basic parts of the transformer? What are the parts of transformer? First part of the transformer is transformer tank. Okay, first part of the transformer is transformer tank. Then what is the function of this transformer tank is that transformer tank carries all the winding and all the core structure of the transformer. Okay, transformer is a cylindrical transformer tank is a cylindrical type of drum where all the transformer assembly inside the transformer tank we keep all the transformer assembly with transformer oil. This type of this transformer tank is made from the sheet metal. Okay, from sheet metal having low reluctance. Okay, after that, then second is winding. Second part is winding. There are two types of winding in the transformer. First is cylindrical type of winding and second is a sandwich type of winding. Two types of winding used in the transformer. First is a cylindrical winding and second is a sandwich type of winding. And the material used for the transformer winding is pure copper. Okay, if the winding is removed from the transformer having doesn't meaning. Okay, transformer having doesn't meaning means transformer winding is the major part of the transformer. Next is conservator. Conservator is the external device of transformer tank where all the transformer oil is reserved. Okay, transformer oil is reserved while the action of contraction means transformer oil level is decreased. At that time, conservator gives the transformer oil to the transformer tank, and at the time of expansion means inside the transformer tank oil level is increased. At that time, conservator taken extra oil from the transformer tank and gives to the conservator. Okay, this is the main function of conservator, and this conservator also made from the sheet metal type of material. Okay, after that, next is a Buckles relay. This Buckles relay is a special type of relay which operated on the fumes or the gases. Means it is gas operated relay. Okay, what is the main function of this Buckles relay? This Buckles relay is located inside the tube between conservator and transformer tank. At the time of expansion and contraction, transformer oil with fumes or gases travels from this pipe. At the time of expansion, number of fumes are generated or liberated from the transformer oil. At that time, these fumes breaks the Buckles relay and transformer is protected from the heavy load or heavy current. This is the main function of that Buckles relay. After that, explosion vent. When tremendous amount of gases is liberated in the transformer oil, that time the explosion vent is burst and these gases passing to the air. That means when high pressure gases are produced in the transformer tank, instead of bursting of transformer, it bursts the explosion vent. The explosion vent, the opening of the explosion vent is covered by the aluminum foil or the bakelite material. At the time of explosion, this bakelite material or the aluminum foil is break. Okay. After that, tubes are the cooling tube. These are the cooling tube which circulate the transformer coil to decrease its temperature and to maintain the transformer oil temperature constant or at a room temperature. Okay, then what are the types of transformer? The first type of transformer is a core type of transformer. These types are depending upon the structure of the core. Okay, not depend upon the voltage level. On depending upon the voltage level, there are single phase or three phase transformer, but this classification is depending upon the structure or the nature of the core. The first type is core type of transformer, second is the shell type of transformer, and third is the berry type of transformer. So let us here discuss first type, core type of transformer. Okay, so we draw here circuit diagram of core type of transformer. This core type of transformer having two yoke and two leaves, and both windings are bound on the side link of the core. This is the yoke, and vertical portion is called leaf, and horizontal portion also called yoke. Means there are two vertical beams present and two horizontal beams present. The horizontal beam called leaf and vertical beam called yoke. Okay. In the core type of transformer, there are two yoke and two leaves are present, and here only single winding is present. Okay, single magnetic circuit is present. Both the windings bound on the side leg of the core. Both the windings bound on the side leg of the core. Single magnetic circuit is present. Single window is present. Okay, here only one window is present and only one magnetic circuit is present. Then both the winding wound outside the surrounding the core. Both the windings surrounding the core or outside the core. After that, the type of winding is cylindrical type of winding is used in the core type of transformer. So if the winding surround the core at the time of repairing, we have to remove only one yoke. Okay, if we remove any one yoke, we can repair the transformer winding. That means the repairing is very easy in case of core type of transformer. Okay, then the winding are outside the core, so the natural cooling is very effective in case of core type of transformer. Okay, then this core shape is like a rectangular type. Okay, this is a core type of transformer. After that, we have to discuss shell type of transformer. This is the circuit diagram of shell type of transformer. What we observe here, there are two yokes, 2 yoke and 3 limb, 1 limb, 2 and limb 3. That means in the core type of transformer there are 3 type of limbs, limb 1, limb 2 and limb 3. Then what we see here, the both the windings means this is the primary and this one is secondary. Both the windings are located on the central limb, right? Both the windings located on a central limb, not on limb 1 or not on a limb 3. And if the 2 windings are present, 3 limbs are present, the magnetic circuit is also in number 2. Okay, means 2 magnetic circuits are present here, and the type of and the core is encircles the winding, not a winding encircles the core. Here what happens? Core encircles the winding and winding is inside the core. Okay, in case of shell type of transformer. So this type of winding is called a sandwich type of winding. Okay, because it's sandwiching the 2 LV inside 1 HV. It's sandwiching the winding. So this type of winding is called sandwich type of winding. And here 2 separate magnetic circuits are present. So if we have to repair this type of transformer, we have to remove the number of laminations to repair this type of transformer. Means the maintenance is not easy in this case of transformer, and we have to so the winding is inside the core. So we have to provide a extra or separate cooling to this type of transformer. So here natural cooling is not possible because core encircles the winding, not a winding encircles the core. So the cooling is not better in case of this type of transformer. We have to provide a separate cooling to this type of transformer. Okay, then here primary and secondary, both the windings are mounted on a central limb. So this is a shell type of transformer. It is a very different to the core type of transformer. So we discuss what is the comparison between shell type and core type transformer. So what is the comparison between shell and core type transformer? The core type transformer having a single magnetic circuit, while the shell type of transformer there are 2 magnetic circuits present. Means in core type single magnetic circuit is present, in core type and shell type 2 magnetic circuits are present. Okay, in case of core type of transformer, cylindrical type of winding is used, cylindrical concentric type of winding used in case of core type of transformer. In case of shell type of transformer, sandwich type of winding is used. In case of core type of transformer, winding encircles the core, but in case of shell type of transformer, core encircles the winding. Okay, here winding encircles the core, and here core encircles the winding. Okay, and in core type of transformer, natural cooling is very effective, but in case of shell type of transformer, natural cooling is not more effective. Okay, in case of core type of transformer, repairing is very easy. We have to remove only one type of yoke, but in case of shell type of transformer, we have to remove large number of laminations. So the repairing is not easy in case of the core type of transformer. Okay, this is the comparison between shell type and core type of transformer. Then third type of transformer is a Bell type of transformer. Third is a Berry type of transformer. This is a very different type of transformer. In shell and core we also hear only single magnetic circuit, double magnetic circuit, but this dairy type of transformer is a multi-magnetic circuit type of transformer. Here, number of magnetic circuits are present, and the structure of the core is like the spoke of a wheel. You know the spoke of wheel, then you can better understand the type of dairy type of transformer. You can better understand if you know the spoke of the wheel. This type of structure is present in case of dairy type of transformer. There are multi-magnetic circuits are present, and the whole assembly is fitted in the cylindrical tap. Here multi-magnetic circuits, multi-yokes, multi-limbs are present in case of a dairy type of transformer, but this type of transformer is rarely used. So not involved in our subject or not involved in our syllabus, because this type of transformer is very rare. So what we study in this chapter, what is meant by transformer, what is the definition of transformer, what is the principle of transformer, after that what is the constructional parts of the transformer, after that the types of transformer depending upon their construction. Next lecture we will discuss about the other types of transformer, kVA rating of transformer, why transformer is not operated on DC supply, then what is the EMF equation of transformer, what is the voltage ratio, what is the current ratio, etc. We will discuss in the next lecture. Thank you.